I wanted to make sure that you guys are doing the friction lab right, so I wanted to actually run through an example. So suppose I've got, say, a 0.15 kilogram block, and I've got two of these guys, these little 100-gram masses that we put on. But let's remember, this is going to be 0.1 kilograms and 0.1 kilograms each. So if I were to draw a picture of the system, we're going to have this block with the two little masses on it, and I want to be clear that this is going to be a total of 0.2 kilograms on top, 0.155 on the bottom, or 0.15 on the bottom. And then, of course, we're going to have this spring scale pulling it. So let's be really clear. When I've got this whole setup here, and I want to get the force diagram, I'm going to have the normal force, and I'm going to have the gravity force, or the weight. And so when I calculate the mass of this whole thing, I'm going to end up getting 0.2 plus 0.15, which is going to be 0.35 kilograms of mass. This is M. Now, if I ask you to get the normal force, that means that the normal force, when we look at the fact that this is balanced, that this thing neither flies up into the air nor crashes through the ground, we're going to get that the normal force equals the weight because it doesn't move vertically. It's totally balanced in that direction. That does not mean that the normal force is 0.35 kilograms. Let's get the weight. The weight is going to be 0.35 times 9.8. And that's going to actually work out to 3.43 newtons, which is the weight. That balances the normal force. Now, let's say when I pull the mass with the spring scale, we're going to get a new free body diagram that looks like this. Again, so I'll draw the spring scale force like this. When I draw the new force diagram, I'm going to have the normal force, I'm going to have the gravity force. I guess in the previous free body diagram I drew that as F sub n. I have the tension from the spring scale and the friction force opposing that. So when I read the tension off the scale, that's what balances my friction. So if suppose I read a tension of 1 Newton, that means my kinetic friction is equal to 1 Newton because we're moving at constant velocity, and that implies that the force is balanced. The last little thing I want to say here is when you go to your data, okay, let's just kind of record. So I told you 0, 0 should be one of your points. So we want to get that down. And for this last one, we got a normal force of 3.43 newtons and a kinetic friction of 1 newton. Now my concern is that you guys are going back and you're putting the wrong data down. I just want to write one more column here. You should not write this column, but the mass that you have for this object is 0.35 kilograms. I saw a lot of people writing their kilograms in their normal force. Make absolutely sure you have not done that. So now this is data for 0.35 kilograms where we've got two masses. What you'd want to do for your next data point is you'd want to have one more 100-gram mass. So 1, 2, 3. So this is now 0.3 kilograms. This is 0.15 kilograms for the block still. So we'd end up getting 0.45 kilograms of mass, but what we want to put in this column here is the normal force equals the weight, which is going to be 0.45 times 9.8. And when we work that out, we get 4.41 newtons. And then you measure the pulling force and write that down here. Remember, your y-axis is friction, and your x-axis is normal force. You want to plot that and get the slope. Okay? Be really careful about this. I saw a lot of careless mistakes. So you may need to go back and completely redo the lab. And if you need to do that, I suggest you do that now.